So this is lesson Algebra 2, lesson 48, absolute value equations. We've learned so far how to graph lines, and then we're talking about today about absolute value graph. And that's our objective for today, is how to graph that. So what does an absolute value graph look like? Well, if I were to draw or make a coordinate plane, an x and y axis, let's say this was my x-axis and this is my y. Okay, an absolute value graph looks like the following. It would look like this. Okay, there would be two lines and they would stop at a point. This point right here at the end is called the vertex. Okay. But you're going to notice that the graph of an absolute value line is always going to be symmetrical, and it's kind of pointy, okay? So we've talked about before parabola. Remember parabolas? Or a quadratic graph. It looks like this. Remember this from like a few months ago? We're going to look at these again. It looks the similar way. There's a vertex, but today we're looking at the absolute value equation, which is two straight lines meeting at a vertex. Okay? So that's really the difference. So what I'd like you to do is just write this down, what a graph looks like. Okay, so you're ready? And just point out what the vertex is. It's really important that you know what your vertex is. We have to start with this, and then we're able to work with the rest of the problem. All right, continuing on. The other thing we kind of have to start thinking about also is the standard form of the absolute value equation. The standard form of a... Sorry about that. My computer's running slow today. The standard form of an absolute value equation is the following: y is equal to the absolute value of mx plus b plus c, which is very similar to the standard form of a line. Remember, standard form of a line was y is equal to mx plus b. Okay, so this is a line. Absolute value equation is very similar. You see you have an mx plus b, and we have an mx plus b here. Everything's equal to y. Okay? So, I want you to notice the similarity. The other thing I want you to notice, there's a c that's added to the absolute value sign. Okay? Since the vertex is kind of a central point, you need to memorize the vertex location. The way you figure out the coordinate is it's negative b over m c. The c is an added number that's out here outside the absolute value. Okay. So I don't really want you to focus too much on the line. If you want to know the line or see the similarity, you can. But it's really all you really need to focus on is figuring out what m, b, and c are. Okay. Yeah, you should write this down. Oh yeah, this is very important information. Okay. Here are the steps, in case you didn't get them. Again, the big thing is you're figuring out everything is set equal to y. Identify your m, b, and c. Calculate the vertex. The vertex is very important, and then make a table and graph the points. So once you do it a couple times, it's not that hard. So, but it is foreign. So this is a brand new type of equation. So here we go. Number one. Please watch carefully. Number one. Number one, the first thing I'm trying to figure out is it equal to set equal to y? It is. Then I want to figure out what my M, B, and C are. So I think about what is my standard form. Well, I know my standard form is y is equal to the absolute value of mx plus b, all of that plus c. Okay, so I'm thinking, what's my m? Well, m is the number in front of the x here, and I know m, since there is no number there, m should be 1 because that represents the coefficient there. The b is also 1, right, because your b is right here. And then your c, we don't have a c here, so when we don't have a number there, we're going to assume that it's 0 because there's nothing there, so we're adding 0 there. Okay. So we start with this information, then we figure out our vertex first. The vertex, when we start with, the coordinate is negative b over m, comma c. That's going to be your vertex. So we plug in our numbers. We got negative. We have our b, which is 1, over m, which is also 1, comma c. Our c is 0 in this case. So we simplify that. Negative 1 over 1 is just negative 1. So we know that the vertex on this particular absolute value equation is going to be at negative 1, 0. So it's going to be there. So I'm going to put that there, and I'm going to put a little v there to represent my vertex. The next thing now, I'm going to make a table of values. So whenever you need to graph anything, you make a table of values. I'm going to make an XY table. Since I know my vertex is at negative 1 and the output would be 0, I'm going to pick a couple numbers that are around it. I'll pick 2 bigger numbers for x and 2 smaller numbers for x. And I work these out, okay? So this is the longer part. So I'm going to plug in negative 3 first. So we got y is equal to the absolute value of, I'm plugging in negative 3 for x, plus 1. Negative 3 plus 1 is 2, so we want to find the absolute value of negative 2, which is just 2. So the first input, if I put negative 3 into the equation, I get 2 out of the equation. Next, I'm going to do negative 2. Y is equal to the absolute value of negative 2, plus 1, which is equal to the absolute value of negative 1, which is just equal to 1. So plug that in. Now we put in 0. Y is equal to the absolute value of 0 plus 1. 0 plus 1 is 1. Absolute value of 1 is 1. Putting in 1 now. Y is equal to the absolute value of 1 plus 1, which is the absolute value of 2. So y is equal to 2. Okay, so now I made my XY table. Now I know for these inputs, I have these outputs. This was my vertex. I already plotted that. Now I'm going to plot the other one. So let's start. Negative 3, positive 2. So negative 3, positive 2 should have a point right here. Negative 2, 1. We already have the vertex. And then we have 0, 1, and 1, 2. Okay. Now you're noticing we have a nice V here, so we use our straight edge. You need to use a straight edge in this one because you want to make sure that you have a nice, perfect looking V, okay? Because the V might not look like it's symmetrical, but it's supposed to look symmetrical after you plot the points, okay? Again, all I did is figured out what's my M, B, and C, started figuring out my vertex, then I made an XY table calculating the surrounding points, and then I plotted my points and graphed. Okay, so that's number 1. Watch me do number 2. It's a little bit more difficult. Number 2, it's in standard form. Y is isolated, so that's confirmed. I'm identifying M, B, and C. So M is equal to 3, B is 2, C is equal to negative 1. Okay, vertex. My vertex will be at negative b over m, comma c. So we're going to have negative b. So our b in this case is 2, so it's negative 2 over m, which is 3, c, which is negative 1. Okay, so my vertex will be at negative 2/3, 1. Okay, or negative 1. So I'm going to go negative 2/3. I'm not going to go all the way to 1. I'm going to go just to about 2/3 of the way and then down 1. So my vertex will be here. right there. Okay? Next is I'm going to pick points around that, so I'm going to make an XY table. So we got X and Y. I'm going to put my vertex in the middle, -2/3, -1. Pick two numbers that are smaller, so I'm going to pick the next whole numbers, -1 and -2. Then I'm going to pick two bigger numbers, 0, 0 and 1, right? Because -2/3 is a fraction. And then I'm going to solve for these, okay? So starting with -2, we have y is equal to the negative absolute value of 3. Oh boy, I need more room here. Start a little bit this way. Y is equal to the absolute value, or the negative absolute value of 3 times x. X in this case is -2. Plus 2. All of that minus 1. So 3 times -2 is -6. -6 plus 2 is -4. All of that minus 1. Absolute value of -4 is +4 times the negative sign is -4. -4 minus 1 is -5. Okay, so when I put a -2, I get -5. Next, I'm going to put a -1. Let's do that over here. I have some space over here. Okay, so we got, actually I don't have too much space. Y is equal to negative absolute value of 3 times 3 times -1 plus 2 minus 1. Okay, 3 times -1 is -3, plus 2 is -1. Absolute value of -1 is 1 times negative sign is -1. -1 minus 1 is -2. So y is equal to 2. Okay? Or -2. Then I'm going to put in 0. We got 3 times 0. So y is equal to absolute value of 3 times 0 plus 2 minus 1. 3 times 0 is 0 plus 2 is 2. 2 times, or absolute value of 2 is 2 times negative sign is -2 minus 1 is -3. And then we got 1 is next. I'm going to plug that one in. So we got y is equal to the negative absolute value of 3 times 1 plus 2 minus 1. Sorry, it's at the edge there. Okay, so we got 3 times 1 is 3, plus 2 is 5, absolute value of 5 is 5, times the negative is -5, minus 1 is -6, okay? So my XY table is looking pretty crazy here, right? I'm kind of boxing it. So on this example, do any of these numbers repeat on the y's? No. What about in the first example? Did anything repeat? Yeah, it did, okay? You might say, did I do it wrong? No, I didn't do it wrong. The next thing you have to do is graph it. I wanted to show you that they don't always have to be symmetrical. So on this example, I'm going to graph these. So we got -2, -5.
So we have to do every single column?
Yes, and then -1, -2. And then 0, -3. And then 1, -6. Now, you see, are any of my points lining up together?
No.
No. Next thing you have to do is use your straight edge and graph. Believe it or not, these points all line up. Does this look like a symmetrical V?
Yep.
Yeah. So even though your points aren't lined up, your graph needs to look like a perfect V, okay? So that's the hard part about number 2. So there's a lot of writing there. I went through a lot.
Does it get harder or is it just like the basic?
This is medium hard problem right here.
So are we going to do anything else today?
It might be, oh no, I don't think you'll do anything harder.
So this is the hardest thing for
This is the hardest problem that I'm showing you. you have to be able to do this for homework tonight, but it just takes a little time, okay? All right?
What is this at the end? 2 what? 2 negative 1?
Yeah, 1
Plus 2
absolute
negative
value negative 1.
Uh-huh. Okay, so what I'd like you to do is turn to your neighbor, talk about the process. 1 still 2 is about number 1, 2 still 1 is about number 2. And I want you to talk about the whole process, okay? I really need you to focus on how we get the vertex, and then how we do the table, and how we plot the points, and why we want to draw the lines, and sometimes why it doesn't line up, okay? Ready, set, go. So number 3, I want you to tell your neighbors what A, B, and C are. I'm sorry, M, B, and C are. M, B, and C. Okay, M, B, and C. What's M, everyone?
1.
Good. B? -3. C?
0.
Good, okay. So if that's the case, what's my vertex going to be?
Slow, nice and slow.
How is that?
So we got negative B over M, so we got negative B over M. So what's my vertex going to be?
No, wouldn't it be 3
3 1.
to negative 3? 3
and
See, I'm already smart, just sitting right next to you. Rubs off.
Yeah, well, when you went there paper, I guess that's good.
Yeah.
Tiger.
Hey, you don't have to be jealous.
Just what?
Sitting in the front, close to me. Okay. 3-0. Okay?
Yeah, I'll see you in a second.
Okay. Oh, I got a question. Can we predict which way this is going to open?
Up.
Up. How do we know it's going to open up?
It's not
It's
negative.
-3.
It's positive.
No.
Oh, yeah, positive.
Okay, the way we know is look at the number in the front of the absolute value sign. Look up in the front. What number is there or not there? Oh, come on. What is wrong? Is there anything here? No. So what's the imaginary number when there's nothing else? 1. Positive or negative 1?
Positive.
Positive. So it's a positive 1. It means it's going to open
I
up.
got it.
Okay. So now we have to make our XY table. It's going to be 3, 0. And then we got, what 2 numbers that are bigger than 3? 4 and 5. And then what are 2 numbers that are smaller than 3? 2, 1. Okay, did you see how I set those up, everyone? Yes? Okay, so what happens when I plug in 1? What do I get when I plug in 1? 2? Okay. What happens when I plug in 2?
1.
1. Good. What happens when I plug in 4?
1.
Good. What happens when I plug in 5?
2.
Good. Are these symmetrical?
Yep.
Yeah, this is an easier problem because you don't have to deal with fractions or anything. So now we're going to plot our points. Everyone's plotting their points. You're going to show me your answers. What? No, because I'm working. I don't really. It's not like it's fun for me. I just sit there and talk. Well, it's fun, but okay. Anyways, so plotting your points. You should have points as follows. Ooh. Okay, so that's the way your graph should look. Number 4. Okay, number 4. Now, number 4, can you predict which way is it going to open, up or down?
Negative. Down.
Down, right? Good. Okay. So, number 4. Okay. A, B, and C, or M is what? 3. B? What's B? B is 1?
0.
0. There is no B.
Come on, Billy.
B is 2.
Okay.
Just tell Junior it's
Everybody's asking me the smart one.
Okay, so what's my vertex going to be at? 0, 2, right? Because B is already 0, so you could assume it's going to be 0, 2, because we have negative 0 over 3, 2, and 0 divided by 3 is just 0, so it's going to be 0, 2. Okay? That's your vertex. So this is nice. If it's on the point or on a lattice point, it's going to open down. So let's do our XY table. We have 0, 2. Pick 2 points that are, or 2 numbers that are bigger than 0. What are 2 numbers bigger than 0? 1 and 2. Pick 2 numbers that are smaller than 0. Okay, good. Now, if I plug in negative 2, what do I get?
Negative 4, right?
Negative 4. If I plug in negative 1, what do I get?
Negative 1.
Negative 1. Good. If I plug in 1, what do I get?
Negative 1.
Good. If I plug in 2, what do I get?
Negative 4.
Negative 4. Okay? So, plug in my points in. Using your straight edge. Get your ID cards out so it looks really nice. All right, and the last check you want to do, you want to ask yourself, is my graph look symmetrical? Does it look symmetrical?
Yes.
Yes. Okay, it does. It has to look even. Okay, if it doesn't look like an even symmetrical graph, then it's wrong. So if you have like a line that's looking like out this way, or you have one that's there, or you have one in the middle, you did it wrong. Okay, so you have to make sure you double check your work. The other thing is, look at the slope between the points. What's the slope between here and here? What's the slope there? What is it? 3, 1. Okay. What about the slope between here and here?
I'm guessing
3, 1.
3, 1. Oh, it's the same. So now let's look at the opposite slope. Shh. What's the slope between here and here?
3, 1.
Nope.
Negative.
Negative 3, 1, right? What's the slope between here and here? Ah, good. So it's like it's a negative of the slope, right? Does that make sense? It's a negative. This slope from here to here you said was 3 over 1, right?
It's just opposite, right?
Well, it's not just opposite. It's negative 3 over 1. It's negative, right? Makes sense? So look at the last example. What's the slope from here to here?
1, 1.
1 over 1. What's the slope from here to here?
Negative.
Negative 1, 1, right? Does that make sense?
Yeah.
So that's a little clue, right? So you need to start looking at graphs and start saying, oh, this is a clue. If my slope here is negative 1, this one's going to be positive 1. Or vice versa. Here we have a positive 3 over 1. It's negative 3. Okay? So that ends the lesson for today. Yes.